a couple of our students have put up polynomial expressions that they came up with. So here's the long version with all the blocks they pulled out of the workmat, and then underneath they simplified it for us. So Carly, could you describe what your group did here in order to simplify this equation?
Well, wait, like in block form?
Sure, yeah. How did you get rid of variables, or how did you combine them?
Well, we were able to simplify, we were able to take away, we were able to take away a 1 from, we were able to take,
Okay, so you took away a 1?
from each side, like, yeah.
Okay.
And 25 from each side.
Okay.
And x, the little x.
Okay. And when you say from each side, what are your two different sides?
The minus area and the positive.
Okay. So they went through and canceled out what was in their minus area and what was in their plus area, what was the same. Okay, and then what did you do next?
Then we just put them together and then just added them all up as negative y squared plus y plus xy plus 1.
Okay, good. So this is their simplified expression down here. All right, and how about this group right here? Emma, what did you guys do with your expression?
Well, we took away 10 from each side, and then we took away xy
So 10 from this side and 10 from where else?
from the positive.
Okay.
And then we took away xy from the negative.
Okay.
And then it's negative 2y plus x squared plus 5x.
Okay, good. And I have a question. Both of these were written with our minus area, and then we added on our positive area. Is there another way that we can write these expressions? Winnie? Sure, why don't you do it with this example right here? Okay, and tell us what you're doing here.
I wrote the positive side, now we're going to add a minus sign, and do 2y
Okay, thank you. What did you say, Drew?
Well, before she added the parentheses, you couldn't do negative 2y and then do plus 10 or plus xy, because that means
Negative, that was minus.
But then when you're saying minus this and then plus that, that would make it positive if you didn't have the parentheses.
Okay, can someone else, thank you, Winnie, can someone else restate what Drew just said here? He said we can't put this in without having the parentheses in there. Why is that, Max?
Because it just has to do with like order of operation, because like with the thing, sorry, it would go like you would add on the things at the last, like right there.
Okay.
Before, like after you subtracted the thing.
Okay, so if I didn't have it in, you're saying I would add on this plus 10 and plus xy?
Well, yeah, it'd be like you'd be. It would just be xy minus 2y instead of that whole expression minus that whole expression.
Okay, good. And are my 10 and my xy in my positive area or in my negative area? Carly?
Negative.
They're in the negative area. So if I don't have this parentheses here, then it tells me to add them, which would mean they were in the positive area, which isn't true. So it's really important that we remember to put that parentheses around everything in the minus area here. All right, can somebody explain to me, is this, Anya, is this yours?
Yes.
Can you explain to me what you did here?
Yeah. Oh, sorry. I forgot to put the parentheses. Right. So we did.
Wait, what did you just say?
We forgot to put the parentheses.
And where do they go?
Well, like there's the minus sign, and after, like between the minus sign and the 3, and then.
Okay, so this whole thing is your minus area right here.
Yeah.
Okay, that's important, like we just went over. Okay, go ahead.
We had originally we had the 18 and then stuff.
why did you do that?
Because 5 is more than 3, and 5 minus 3 equals 2, so that's the leftover. The leftover that would be where it's supposed to take out.
Okay, so you said 5 minus 3 is 2. So you took away 3?
Well, like, yeah, so we took away 3 from that, so we had to leave 2.
Alright, so we took away 3x from both sides here, so we got this 2x here. Okay. Okay, and then what else did you do?
And we took away the 4,
Uh-huh.
and we replaced, and then we replaced the 8. Why did we say 14? Then we
Because you took away
Don't.
4.
Yeah, because and then we put the we took 4 from the 18.
Okay, so we took 4 from the 18, and then what did we get?
We got wait, 14?
Okay, yeah, what's 18 minus 4?
And
14.
Okay. And then what else do we have?
that was oh yeah, and then we just the negative the x we just
Okay, and why is it negative? It says plus x squared here, but then why is it negative?
in the parentheses with the opposite sign, so that makes it negative.
Okay, does everybody hear what she just said?
Yes.
So why is this x squared negative here? Even though it says plus x squared here? Carly?
Because it's the opposite of the positive area, and that makes it negative.
Okay, so it's the opposite. So we have this minus sign in front here, so it's the opposite of what's inside here, so we have the negative x squared. Does anybody have a question about that? Okay, so when I'm working with these expressions and I have some in this area and some in that area, when can I cancel them out and what can I cancel out? Just in general with any algebraic expression. Sarah?
If they're the same number in the negative as the positive.
Okay, so if I have the same number in the negative area as the positive area, so I have 10 in the negative here and 10 in the positive here, and what do I do to get rid of that 10? Benny?
Well, I was going to say that you can take away the like terms. Like, say you had 1x and then another 1x, or like 2x. You could take away 1x from that and the other one.
Okay, so an example might be, let's see, like this one right here where I have 5x in the positive and 3x in the
Yeah.
negative. And what can I do there?
Well, you can take away as much as you can without going like negative. So with the 3x, you can take 3x from the negative and 3x from the positive.
Okay. Carly?
Well, they've always said in that, like, what you do to one side, you have to do to the other side.
Okay.
So if there's like 3 in the minus area and 5 on the other, if you take away the 3 from the minus area, then you have to take away 3 from the positive area
Okay.
too.
That's a really good point. What we do to one part, we have to do to another. So if I have a minus 3 and I have a plus 3, if I take away that minus 3, I have to take minus 3 away from the plus 3 too. Just like here, I had a 5x and a minus 3x. I took away that minus 3x, so I had to do minus 3x and the 5x to give me my 2x in the end. Now, I heard Benny mention the words like terms. Do you guys remember when we worked with those? Drew?
Yeah, it's.
You do remember when we worked with them? And what did we do last time with like terms? What's the concept that we use like terms for? Emma?
We combined them,
Okay.
but I think this time we're subtracting them.
Okay, so when we combined like terms, what did we do?
Added.
Added them. Alright. And Emma, what did you just say we're doing here?
Subtracting like terms.
Subtracting like terms. Does anyone disagree with that? Are we subtracting like terms here? Yeah? And how are we subtracting like terms? Uh-huh.
We're simplifying the problem.
Okay.
And then we're taking away some terms.
Okay. So when I decide what I'm going to subtract, how do I decide what I can subtract? Anna?
If we have the same numerator.
Okay, just like we talked talked about before. They have the same variable or like terms. Just like we did with addition, where we figured out which terms were the same and we combined them by adding them. Here, we're figuring out which terms are the same and we're subtracting them. So we're taking whatever's in the minus area and we're subtracting that from the positive area. So if I have a 10 in the minus area and a 10 in the positive area, and these are like terms, then I can subtract them from each other. Does anyone have a question about that? So if I have two polynomial expressions and I want to subtract one from the other, how do I simplify that? Can someone give me a summary of what we were just talking about? Olivia?
Well, if you have two different ones, you like find like terms inside them.
Uh-huh.
So like for example, like 10 and 10.
Yeah.
So you can subtract those, but if you can also have 10 and 5, so you can subtract 5 from both because they would cancel each other out. So you find all the ones that are similar, and then you can cancel the ones out that would equal 0, and let them do it first.
Okay, great. So we find the terms that are similar in the positive and the negative expression, and then we can subtract like terms. Does anyone have a question about that? Okay, so, all right, so the next thing